Hey, nurses. Had a few questions come up about this particular worksheet you guys are working on in one of your old classes. I just wanted to walk you through a couple of them. I don't want to do all of them for you because I think that would defeat the purpose of you guys learning anything. But I do want to kind of get you on the right path because I know a couple people were kind of stuck. With these types of questions, you really have to pay attention. The big thing is paying attention to what's being asked. You know, like in number 1, it's telling you how many milliliters should be given. Calculate the milliliters per hour in number 2. How many milligrams should we give per dose in number 3? So we're paying attention to what's being asked of us based on what's given to us. So when you're given things like number 1, it tells us 6,500 units of subcutaneous has been ordered. It is available at 1,500 units per milliliter. Now this is a question where we're going to use our D divided by H times Q formula because it tells us how something is given or how it's available or how it comes. It tells us that particular set of information and then asks us based on what's given. Because it comes per milliliter, I want to know how many milliliters should be given. So I know based on what's given to me, I know that if what's ordered is 6,500 units, and let's just call it U, but it comes in 1,500 units. Remember, that's dose over what we have on hand. Per milliliter, your quantity is your per 1 milliliter. That was what was right over here, the per milliliter. So I should be able to figure out. And again, remember what happened. Some of you guys I've told this to, and some of you guys I may not have. If you look at the 6,500 units over 1,500 units, you can kind of look at that as a fraction. I know we hate fractions. We want to always avoid fractions. But if we look at that as a fraction, 6,500 and 1,500 are not the same, so they don't really cancel out. But units technically do cancel out. If they're the same, you can always cancel them out. So that's why we always want D and H to be the same in terms of what unit it's in. I know that number 1 happens to be in units, but since they're both in units, they cancel out, meaning that in the end of this operation, when I take 6,500 divided by 1,500 times 1, I'm going to end up with the only unit I have left is milliliters. So when I do that, 6,500 divided by 1,500, when I do that, I get about 4.33, so I get 4.3 repeating, but that's about 4.3 milliliters, the unit that I was left with. And again, remember, that was the question that's being asked up here, so that's what I wanted. So I know that that's because that's what I'm left with, that's what I have, and that's what was being asked. Now, in number 2, that is an IV question. There are 4 different IV formulas that you guys will have to use at some point. I have a separate video for that, and I'll send that with that. You just have to kind of pay attention again because it's asking me for milliliters per hour. I know I need the flow rate. So when I need, again, that's something where we have to kind of consider the units there, that if I need milliliters in hours, then that's how I calculate that. I just take whatever milliliters in my hours are that are given in the problem, and that's the only thing I need. So because that's what's being asked, milliliters per hour, I only need milliliters and hours. This is extra information. That 250 milligrams is just extra. So all I have to do is take 100 divided by 0.5. That's milliliters divided by hours. Being cautious that if your time is ever given in minutes, that you'll have to convert to hours because I need milliliters and hours. The big question that I kept hearing was ones like number 3. So I'm going to walk you guys through number 3 because that one was kind of a tricky one. The question is asking me how many milligrams would I give per dose. Now, with this, based on what's told to me in the problem, that I have a medication that is administered at 1,500 milligrams per kilogram per day, meaning that any person who takes this particular medication would take 15 milligrams per day, or I'm sorry, for every kilogram that they weigh. So if, for instance, they weighed 1 kilogram, then that means they would take 15 milligrams per day. Whereas a patient who weighed 2 kilograms would take twice that amount. They would end up taking 30 milligrams per day. Or if they weighed 3 kilograms, then therefore they would need 3 times that amount, so they would take 45 milligrams per day. And I could keep going, and you guys see where I'm going to go with this. That for every amount, or every kilogram that a person weighs, they take that amount of that drug. So our patient, who's 130 pounds, well, that's not kilograms. Again, I need to figure out what that is in kilograms. So the quick way to take 130 and convert it to kilograms, if you guys recall from doing our conversions, is simply just to divide by 2.2. For those of you guys who are remembering your conversions, the way that you learned it, I taught you to look at your unknown and your known. 130 pounds over X amount of kilograms. Well, our known for pounds to kilograms is 2.2, well, that's a point, pounds for every 1 kilogram. So therefore, we're taking 130 times 1 and then divide it by 2.2. So that's how we know how to convert 130 pounds to kilograms. So when I take 130 divided by 2.2, I get about 59 kilograms. So our patient is about 59 kilograms. So he's going to take 59 times the amount of given drug because, again, it's 15 milligrams per each kilogram. Our patient is 59. So what we end up having to do is take 59 times the 15 milligrams of our medication. So our patient has to take 885 milligrams per day. So let me erase some of this information over here. Let's see if it would erase. It's not going to erase for me. There it goes. So our patient has to take 885 milligrams. But remember, the dosage was 15 milligrams per kilogram per day. So our patient who was 59 kilograms is taking this per day. Okay? So that's not the answer to my question, because the question said, how many milligrams of the medicine would I give per dose, not per day? Well, there's the rest of the information is given in the question as 15 milligrams per kilogram per day of medication in divided doses every 8 hours. So that's kind of the big clue on that one, that it's telling us don't take this 885 milligrams all at one time, although that's what you're going to need in a total day period. But it's saying don't take it all at once. Take it every 8 hours. Well, every 8 hours, if you think about it, the way to kind of figure out how many times it's going to be, there are 24 hours in a day. Well, every 8 hours, if I divide that up, that's 3 times in a day. So what it's telling us is to take this dosage and divide it by 3. And that's what they're going to get in a dose. So if I do that, 885 divided by 3, they're going to take 295 milligrams every 8 hours. And that's what we're looking at per dose. Okay, so now let's take a look at, again, I'm not going to walk you through the entire worksheet, but if we take a look at number 4, that's asking us for something completely different. Again, we have to know our IV formulas. 4 and 5 are kind of asking us the same thing. They're asking us for these drop rates, or I'm sorry, drip rates. Whoops, didn't mean to move that. So drops per minute and drip rate is the same thing. So if we refer back to that IV, those IV formulas, in order for us to calculate a drip rate, oh, excuse me, I didn't mean to do that. In order for us to calculate a drip rate or drops per minute, what I need is I need the total volume of the, whatever we're taking or whatever's ordered. It needs to be in milliliters. It has to be in milliliters. That's what I'm looking for total volume. In an IV, it's a liquid solution, so I just need the milliliters of that particular drug. If it's in liters, we have to convert it. If it's in milligrams, it's probably going to tell us it comes in so many milligrams per milliliter. Because remember, gram is a weight dosage, so we're not going to see an IV given as milligrams. Ones like number 2, it says that the patient is to receive 250 milligrams in a total of 1,500 milliliters. So really all I need in that question is the milliliters. I don't need that extra 250 milligrams. It was just simply telling us how that drug was diluted. And I don't, again, that's extra information that I don't need. I only need the volume in milliliters. Then what's going to happen is I'm going to take that and I'm going to divide it by the time. IVs are usually given per hour or per so many hours. But in drops per minute, when I'm trying to calculate the drops per minute, again, paying attention to what is being asked of us, I need minutes. So my time in this case must be in minutes. So if your time is ever given in hours, we have to convert that to minutes, which is super, super easy because we know that there are 60 minutes in an hour. So therefore, 2 hours we know would be 120 minutes. 3 hours would be 180. What's happening is we're multiplying. So if your time is ever given in hours, remember to convert minutes to hours. Let's make a little side note here. Minutes to hours is simply just, well, that's supposed to be an hour. That's terrible. Is times 60. Okay, so just kind of side note on that. If your time is given in hours, simply just convert it. Oh, I didn't mean minutes to hours. I meant hours to minutes. Sorry, guys. Erase that. Still the same thing, but hours to minutes, so sorry, is times 60. There you go. And then what we're going to do is we're going to take that and multiply it by our drip factor. Let's just call it DF. Drip factor or drop factor. Now, the unit for that is that sometimes it's told to, it's drops per milliliter. So we may see GTT per milliliter. So you can see what's happening here as our units are, which units are the same. Remember, numerator and denominator, if they're the same, they cancel out. And it works in multiplication. It's across different, across numerator, denominator too. So given an example, if I had, let's say, 2 over 3 times 1 over 2, random example, the answer to this is going to be 1/3. If you were to actually work it out, multiply straight across, you'd get 2 over 6, which reduces to 1/3. But how did I do that so quickly? That's because these two are the exact same. And when numbers are the same, what happens is I can cancel them out and then multiply straight across, and I get just 1 and 3. It wouldn't matter if those were 2s, 8s, 7s, 26s, it doesn't matter. If they're the same, they cancel out. The same thing happens with units too. And what's happening in our problem above is that I have, if I look at just my units, just the units, then what I have is milliliters over minutes times drops over milliliters. So you see, we have across each other, we have milliliters and milliliters. So you can see when we multiply this problem out, I'm going to end up with drops over minutes. And again, that's what it's asking us. Drops per minute. Drip rate's the same thing. That's what it means, drips per minute or drops per minute. So that's helping us out there. We're doing the same thing. So what we have to do, again, just like the formula says, take milliliters over minutes, multiply by the drop factor. So taking a look at that number 5 down there, again, this was extra information. I only needed my volume, which is 1,500 milliliters, over 6 hours. Now again, I don't need my time in hours, so what did I do to figure out what that was in minutes? I took 6 times 60, and so instead of that, I'm going to use, it was 6 hours, right? Yep. I'm going to use 360 minutes in my formula here. So don't have to worry about that. It's going to end up being 1,500 divided by 360. Then I'm going to multiply it by the drip factor. It says in the problem the drop factor is 25. So there's how I'd set that up. And I simply just take 1,500 divided by 360, which gives me 4.166666 repeating, but I multiply that by 25 and it gives me 104.166666, which is about 104 drops per minute. Usually drops are rounded to the nearest whole number because you cannot give 0.1666 of a drop. That's impossible. So there's our drops per minute. Alright guys, I'm looking at the next page now. The next page, again, it's going to refer to our formulas for IVs, a couple different options. Looks like number 6 is asking us how long it will take. Very similar to number 2. Number 2 is asking us the same thing. It's going to ask us to use the formula to calculate the time, how long it's going to take, except it's telling us then if it takes this long, then if I started at this time, when will I be finished? So let's take a look at number 7. So our time formula for our IVs is to calculate the time. What I need is I need the volume. So the total volume, again, must be in milliliters. And I'm going to divide it by the flow rate, and I'll just call that F. But the flow rate will be given to us as milliliters per hour. There you go again. We see those units, and what happens is I see the same units there across numerator, denominator. So they're going to cancel out, leaving me with, at the end of this problem, hours. That's what I want. So looking at number 7, if it says the client is to receive 1,000 milliliters, 1,000 milliliters to infuse at a flow rate of 100 milliliters per hour. So there's 100 milliliters per hour. Then when I divide these two, what will happen is it will tell me again, milliliters cancels out, leaves me with 10 hours. So it tells me it's going to take 10 hours. Well, the question is saying, okay, I know it's going to take 10 hours, but it says if I started at 1300, what time will it be complete? Well, what's 10 hours past 1300? Now be careful. Don't add 10 to 1300 because then you would get 1310, which technically that means you've only added 10 minutes. But we need to add 10 hours. So remember, in military time, you're actually adding 1000 to it. So the answer would be finished at 2300 would be our answer on that one. So okay, so looking at ones like number 8 and number 9, very similar to what we were looking at the previous page. They're telling us how that medication comes. So it tells me to give 1,500 units. It comes as 2,500 units per 0.5 milliliters. So calculate the milliliters. Again, that's a D over H times Q formula. Very similar on number 8. Number 10 is very similar to number 3 from the previous page. Milliliters per hour, we did that on the previous page as well. So you guys should be okay on that one. Alright, looking at the third page, I do want to point out that on number 12, watch out for this. Again, I had said to calculate the milliliters per hour, I need milliliters divided by hours. Pay attention to the units that are given to us. We have liters and minutes. Both of those are not the units I'm looking for. I need milliliters divided by hours. But do I know how to convert liters to milliliters? I sure do. Liters to milliliters is a metric formula. 1 liter, again, is either times 1,000 or moving our decimal 3 places to the right to get 1,000 milliliters. So 1,000 milliliters is the same thing as 1 liter. Whereas then 45 minutes, that's completely different. I need to divide by so many hours. Well, on the previous page, we were looking at when we're trying to calculate drops per minute, how to convert hours to minutes. We multiply by 60. Well, minutes to hours, if I need that to be in hours, I'm going to then divide by 60. An easy way to think about that is if time was given in minutes and it gave me 30 minutes, I know 30 minutes is a half an hour. Because what is actually happening is 30 minutes divided by 60 minutes is 0.5. So that's easy. That's how we know that that's half an hour. But this question has given us 45 minutes. But if I do the exact same thing, if I take 45 minutes divided by 60 minutes, then what that's going to give me is another decimal, but this time 0.75. So that means it's 45 minutes is 3/4 of an hour, or 0.75. So on this one, I'm going to take 1,000 divided by 0.75 in order to calculate the milliliters per hour on that one. And I don't want to give you the answer. I want you guys to work that one out. That's the purpose of this worksheet. Let's see. Looks like you've got another drip rate. You guys got that formula. Same thing on number 14. Let's see. I'm looking for this. I think that should help you. How long will it take? Again, that's a time. Number 17 is very similar to number 3 from the previous page. I think we're looking pretty good. And looking at page 4, we're looking pretty good on this one too, because you guys should be able to calculate milliliters per hour for number 18. Numbers 19 through 25, those are your basic conversions. Again, paying attention on those conversions, you guys should know those that, like on number 21, I'm going from milligrams to grams, or number 25, micrograms to milligrams. Because they both end in grams, I know that those are metric conversions, so I'm going to need my metric chart on those. As far as, number 22, milliliters to liters. They both end in liters, so I know that because milliliters to liters, they both end in that same word, I know it's a metric conversion. Now on the rest of them, we have knowns. Milliliters to ounces, I have a known for that. Teaspoons to tablespoons, I have a known for that. Number 24, that one's one that may be new to us. I don't know if you guys are going to come across grains a lot. I know I did not show you guys that in the math class, but there are actually 60 milligrams in a grain. So if you know that known, the known is 1 grain is equal to 60 milligrams, not to be confused with grams, although they sometimes do get confused. So what would end up happening on number 24 is we would use this as our known. So there's our unknown for number 24. And that should at least help you get started on that one. If you have questions on it, let me know. But that's just the known and unknown question. Okay, and I'm looking at page 5 now. Looks like page 5, those are all your basic dosage calculation formulas. Can't talk today. Where again it's the D over H times Q, or D divided by H times Q formula. Dose over hand is another way to look at that. So it looks like they've just given those to you. Don't forget that your D and H, the units have to match up. Otherwise they don't cancel each other out. And watch out for extra information too. Like on number 2, it gives us extra information that 4 to 6 hours as needed for pain. We don't need that. I just need the dosage ordered, so the 45 milligrams, dosage that we have, the 15 milligrams, and the quantity. Now that's a capsule, which means it's per capsule, so our quantity would be 1 in that case. So watch out for that extra information, and like I was saying, make sure D and H are the same. So in ones like number 8, for instance, D and H may not be the same in this one. See how we have 0.6 grams, but then we have 200 milligrams as far as our H. So we're going to have to convert those, or convert one of them. Doesn't matter which one you convert. If you remember from class, I had mentioned to you guys that I'm in a habit of converting everything to milligrams because generally things are given in milligrams. So you can convert that 0.6 grams to milligrams by moving 3 places to the right. So that would be 600 milligrams. And then we would divide by the rest. So 200 milligram tablets, so it'd be per 1 tab. And then we would just end up giving 3 tablets. Again, you could have converted the milligrams to grams down at the bottom, and it would have been 0.2. So you would have had 0.6 divided by 0.2. It does not matter which one you do convert as long as you get them to the same unit. That's the essential thing on these dosage calculation questions. So be aware of that. Looking at page 6, it's the exact same thing, except we're looking at dosage calculations instead of per capsule or per tablet. We're seeing some per milliliter. So be aware of your quantity changing. If you get to one like number 17, your quantity is 5, so don't forget that you're going to end up taking your D divided by H, and then in this case, you're going to have to remember to multiply by 5. Don't forget that change. Then you get down to ones like number 18, and you've got, kind of similar to how we were looking at a couple pages ago, it says that Tylenol was ordered, but it's 10 milligrams per kilogram, which means that it's going to be very specific to each patient who takes this medication. There's no person in the world who weighs just 1 kilogram, but if that was the case, then somebody who just weighed 1 kilogram would only take 10 milligrams of that drug. Again, if they weighed 2 kilograms, then they would take twice the amount, so they would end up having to take 20. So that would be the ordered dose. So the ordered dose is going to be very specific to our patient. So our patient is down here, 18.5 pounds. So don't forget, we're going to have to first take 18.5, divide that by 2.2 in order to figure out, just like we did before, in order to figure out what that person weighs in kilograms. So if we do that, we take 18.5 divided by 2.2. So our patient weighs about 8.4 kilograms. So if they weigh 8.4 kilograms, remember we simply just multiply that by 10, our patient needs 84 milligrams of this drug. But how that medication comes is 165 milligrams per 5 milliliters. So we just take our order dose for our patient, divide it by our dose on hand, and then don't forget to multiply it by your quantity. So in this case, it would be 84 divided by 165, and then times 5. Our patient would end up taking about 2.5 milliliters. So you guys double check my work, make sure I did that correctly, but that's kind of what you would be looking at on number 19 and 20 as well. So just be aware of that. Now that should be it as far as the rest of this worksheet. I think you guys pretty much have it. It's the next page is asking me to show where we would give those syringes or where we would administer that. I guess we draw it on the line. If you guys need help with that, let me know, but I think you guys should be good on this worksheet. So I hope that helps. Let me know if you guys have any more questions.